All right, so we're going to talk about two more theorems in this video. We're going to talk about the fundamental theorem of algebra, and we're going to talk about the conjugate theorem. So the fundamental theorem of algebra is pretty simple. It basically says that the highest exponent, and the name that we call the highest exponent is actually called the degree. So the degree is the largest exponent that is in your polynomial. So the highest exponent in a polynomial tells you how many solutions, roots, or zeros, and remember that solutions, roots, and zeros are the x-intercepts. Now, that only happens when we're talking about real solutions. We will talk about imaginary solutions eventually, coming up very soon. But the highest exponent, the degree, tells me how many solutions that my polynomial can have. So if I'm looking at these three examples, it says, how many roots do the following polynomials have? So in my problem, if I'm asking you what is the highest exponent or the degree, I have 3x cubed minus 4x squared minus 6x plus 2. So my highest degree is 3. That is my largest exponent. So this one can have 3 roots total. All right, so looking at B, so these are not in standard form, which means they're in descending order, but I have negative 6x squared minus 25 plus 4x to the 4th. So my largest exponent is to the 4th, which means that is my degree. So therefore, this has four roots total. Now remember, in order for it to be a root, that doesn't necessarily mean that it's a real root, but it does mean that we're going to have 4 total if we were to factor it all the way down and find the solutions. And we will talk about imaginary in our next section. All right, so then for C, I have 5 minus 12x to the 6th. So my highest exponent is 6, so therefore I have 6 roots. All right, so just to kind of summarize, the fundamental theorem of algebra says that the highest exponent tells you the number of solutions, roots, and zeros. Now, that does not necessarily mean that they're all real. That doesn't mean that they're not all real. It means that we have that many total, and it could be a mixture of real or it could be a mixture of imaginary. And we will talk about how to determine how many real and how many imaginary coming up in our next few sections. All right, so our next theorem is the conjugate theorem. And honestly, the conjugate theorem, the reason we're going to talk about this one, because this theorem does help us understand what happens when we have imaginary or irrational roots. And a polynomial, if it has an irrational or imaginary root, then the conjugate means that that is also a root as well. So basically what that says is a conjugate has a set. It has a set of a plus and a minus. So if you notice right here, I said that the set has a plus and a minus. Now it has a plus and a minus because it comes from the quadratic formula. So if you were to go back and do some real roots that you would find at the x-intercept and do some synthetic division and factor it down, you would eventually come to a basic quadratic problem. You would simplify the polynomial all the way down, and when you did the quadratic formula, and for those of you that are unaware of what the quadratic formula is, that's x equals negative b. Here's that plus or minus that is why we have 2 of them. The square root of b squared minus 4ac, and that's all over 2a. And we are going to talk about that a little bit more in detail, but again, the reason that we have a plus and a minus is because of that quadratic formula when we go to simplify. This quadratic formula is going to either produce 3 things. It's going to produce more real rational roots, it's going to produce irrational roots, or it's going to produce imaginary roots. So if you are not aware of what an imaginary root is, again, we'll talk more in detail later, but when you have the square root of a negative number, that equals I. That I represents an imaginary number because there's no such thing as a square root of a negative number, because the opposite of a square root is it being squared. Well, you're never going to produce a negative value when you have a negative squared. It will always turn into a positive. So given that, the reason we're talking about the conjugate theorem is we're basically saying that these comes in pairs. They come in sets. So I want to state the other root given one root, and then I want you to tell me the type. So looking at A, I have 1 plus the square root of 5. Well, this is going to be an irrational root. I know it's irrational because it's got a square root of 5, and the square root of 5 is not going to, it cannot simplify to be a perfect square. So we know it's irrational. And the other root, so I have 1 minus the square root of 5. I also have 1 plus the square root of 5. That's what I mean by it comes in sets or pairs, is because no matter which one I have, if I'm given the positive, then I have to have the negative. If I'm given the negative, then I have to have also a positive. Okay, so look at B. B is imaginary. I know it's imaginary because it's got that I in the problem. All right, so that imaginary value, I have negative 3I. So that set, that other pair, is going to be positive 3I. Okay, and this, again, this is the conjugate theorem that says that it comes in pairs. So we are looking at 1 plus and 1 minus. C is also going to be imaginary because it has that I in it. So I have 3 plus 2i, so this is going to be 3 minus 2i. And D. D is going to be irrational because I cannot take the square root of 21 and turn it into a perfect number. So this is going to be an irrational root. And for my irrational root, this is going to be positive 21, or the square root of 21. This is my conjugate pair is going to be negative square root of 21. Now, the reason that you need to know this is because when we do start talking about total number of roots and what type of roots we have, you need to be able to understand that if I give you an imaginary root, that it has another root with it. So if I give you the positive imaginary, then you need to know that there is also a negative. And that counts towards your total when it comes to the fundamental theorem of algebra. So this theorem simply says that if I have an irrational or an imaginary root, they come in sets, which means I have a pair, a plus and a minus. If you have any questions about either of these theorems, please don't hesitate to email me or contact me and let me know your question, and I will try to get back to you as soon as possible.